Solving a differential equation using the Laplace transform, you obtain big Y of s equals the quantity s squared plus 21 divided by the quantity s cubed plus s squared. We're asked to write Y of s in the form shown here, which means you want to perform partial fraction decomposition on this fraction here. And then we're asked to find little y of t by finding the inverse Laplace transform of big Y of s. Let's first write this fraction in factored form. So we'd have the quantity s squared plus 21 divided by, notice how the greatest common factor of the denominator is s squared, so we can write the denominator as s squared times the quantity s plus 1. So notice how we have three linear factors. The linear factor of s occurs twice. So we can write this as a sum of three fractions, where the first fraction would be a divided by the linear factor of s, and because the linear factor of s is repeated, we then have plus b divided by s squared, and then plus c divided by the linear factor of s plus 1. So the way I've written this, notice a is equal to f of s, b is equal to g of s, and c is equal to h of s. The next step is to form the basic equation by multiplying both sides of the equation by the least common denominator, which is s squared times the quantity s plus 1. When we do this, we'd have the equation s squared plus 21 equals, when multiplying the right side of the equation by s squared times the quantity s plus 1, for this first fraction, one factor of s would simplify out, so we'd have as times the quantity s plus 1. When multiplying by this fraction, s squared would simplify out, so we'd have plus b times the quantity s plus 1, plus, when multiplying by this fraction, the factor of s plus 1 simplifies out, so we'd have plus c s squared. And now we'll select convenient values of s to determine the values of a, b, and c, so we can write y of s as the sum of these three fractions. So let's first select s equals 0. Notice when s is 0, the left side would be 21. On the right side, this would be 0, and this would be 0, so we would just have b times 1 or b. So we know b, or g of s, must equal 21. And now let's select s equals negative 1. If s equals negative 1, the square of negative 1 is 1 plus 21, that's 22. On the right side, if s is negative 1, this would be 0, and this would be 0, and the square of negative 1 is 1, so we just have c times 1 or c, so now we know c equals 22. And now to find the value of a, let's let s equal, let's say, 1. So if s is 1, the left side is 22, equals the right side, we'd have a times 1 times 2, that's 2a, plus b times 2, that'd be 2b, plus c times 1 squared, that'd be c. And now we'll substitute the values of b and c into the equation and find the value of a. So we'd have 22 equals 2a plus 2 times b would be 42 plus c, which is 22. Notice 42 plus 22 is 64. If we subtract 64 on both sides, we'd have negative 42 equals 2a. Dividing both sides by 2, we have a equals negative 21. So now we can write y of s as a sum of these three fractions, since we now know the value of a, b, and c. Before we do this though, f of s is equal to a, which is negative 21, g of s equals b, which is 21, and h of s equals c, which is 22. And now let's write big Y of s as the sum of these three fractions. We would have big Y of s is equal to a divided by s, which is negative 21 divided by s, plus b divided by s squared, that'd be 21 divided by s squared, plus c divided by the quantity s plus 1, which would be plus 22 divided by the quantity s plus 1. Now to find y of t, we'll take the inverse Laplace transform of both sides of the equation. So we'd have the inverse Laplace transform of big Y of s equals the inverse Laplace transform of negative 21 divided by s plus the inverse Laplace transform of 21 divided by s squared plus the inverse Laplace transform of 22 divided by the quantity s plus 1. So on the left side, the inverse Laplace transform of y of s gives us y of t, which is what we're looking for. And now let's identify the formulas we'll use to find these inverse Laplace transforms. Looking at the table below, we have y of s in the second column and y of t in the first column. So we'll be using the table in this direction, and because our denominator here is just s, we'll use this first row to determine the first inverse Laplace transform. Notice how we have denominator of s here. Here we have denominator of s squared, so we'll use this row here where the denominator is s raised to the power of n plus 1, and finally here we have a denominator of s plus 1, which doesn't look like it's in the form of s minus a, but we can write this sum as a subtraction. We can write this as s minus negative 1. So we'll use these first three rows to determine these inverse Laplace transforms, which will give us y of t. Let's write this first inverse Laplace transform as negative 21 times the inverse Laplace transform of 1 divided by s. Notice in this form it fits the formula perfectly. For the next inverse Laplace transform, let's write this as plus 21 times the inverse Laplace transform of 1 divided by, let's write s squared as s raised to the power of 1 plus 1. So we can easily see that n is equal to 1. And for this last inverse Laplace transform, let's write this as plus 22 times the inverse Laplace transform of 1 divided by, let's write s plus 1 as s minus negative 1. Again, in this form, it fits our formula perfectly. So now we know that y of t is equal to negative 21 times the inverse Laplace transform of 1 over s is equal to 1. So we just have negative 21 times 1. So we can leave this as negative 21. Then we have plus 21 times the inverse Laplace transform of 1 over s raised to the power of 1 plus 1. So notice how our numerator here is n factorial, but because n is 1, 1 factorial is 1, so this does fit the formula perfectly, and therefore the inverse Laplace transform is just 2 to the first, or t, so I have plus 21t, and we have plus 22 times the inverse Laplace transform of 1 divided by the quantity s minus negative 1 fits this form where a equals negative 1, so we have e raised to the power of negative 1 times t, or just e raised to the power of negative t. So this is plus 22 e to the negative t. So this is the inverse Laplace transform of big Y of s. I hope you found this helpful.